So now the last thing that we need to look at in Clause 8 is documenting the tests. So 8771 says that the company shall document pressure tests in a manner that adequately supports the success of the test. The record shall include the reconciliation of any significant pressure deviation experienced during the test. Where inaccuracies or questionable results cannot be reconciled, the test shall be considered unsuccessful. And if you have an unsuccessful test, the solution is you test it again. Another word of caution, that wording, right? Significant pressure deviations. You can talk to 10 people and 10 people will give you 10 different ideas of what constitutes a significant deviation. When you're dealing with chart recorders, my own personal recommendation is that if you can visually see it, you need to be able to explain it, right? From a chart recorder perspective. Had a situation in an investigation a couple years ago where a pipe failed, and during the investigation we asked about testing, and they had said, oh yes, we did a service test just 3 weeks ago and it was fine, and we asked to see the records. We looked at the records, and from our perspective it was very clear. It showed that the pipe was leaking at that time. Their rationale was that they were, rather than measuring center to center, right? You know how when you have an ink pen, it bleeds a little bit either side of the center line? They, at the conclusion of the test, measured the bleed inside to outside, determined that the drop in pressure over 24 hours was less than 1%, and said that that was insignificant. We looked at it and said that, well, no, it's closer to 2.5% if you measure the drop in pressure center to center, but even 1% in 24 hours is significant. Right now, this particular situation went back and forth. They said, well, it was probably temperature. They hadn't run a temperature recorder, so we literally went and looked up the records from Environment Canada for that area, and they had started their test at noon. They ran it 24 hours. The temperatures, and I'm just making it up now just for argument's sake, but we'll say the temperature was minus 10 when they put the test on. This was a buried line. They minus 10 dropped to minus 20 overnight, and then when the sun came out in the morning, warmed back up to minus 5. So in theory, we should have seen a pressure drop down and come back up again. All we saw on the record was a steady and stable drop over the period of 24 hours. So again, they had done a test 3 weeks previous that showed that they had a leak. Right? And what it came down to was arguments over what constitutes a significant pressure deviation. And that's, again, it's from that experience that my recommendation is that if you can see a deviation on the plot, you'd better be able to explain where it's from. Right? 8772 says pressures during tests shall be accurately recorded and identified on pressure recording charts produced to pressure recorders connected to the test sections. Pressure indicating gauges shall be installed where required. Now, as far as the accuracy of the instruments, this is another one that deviates a little bit from the international norms, and we'll show you what the deviation is and why it's important. 8773 says the accuracy of chart recorders shall be verified before and after each pressure test, and the accuracy of other test instruments shall be verified periodically. Again, it's language. You'll notice we're not saying calibrated. Okay, we're saying verified. And the difference between calibrated and verified, calibrated is conducted by an accredited calibration laboratory. It's documented. It has a report that's traceable to a national standard. The report will identify the condition the equipment was received in prior to calibration, what was done for the calibration, and a certificate that it is now calibrated and reading accurately. Okay, verification, the process is very, very similar, if not the same as calibration. The difference is it's something that we can do. Okay, now typically when we use calibrated instruments and they're found out of calibration at the next calibration cycle, okay, we have to look at where was that instrument used, right, where that deviation, right, would have an impact on the results. So let's just say hypothetically, I send my gauge in for calibration, it comes back, it's calibrated, and I use it for a year, okay, and in that year I do 12 tests. Okay, at the end of the year, I send it in for calibration. They send it back with a report that says they received it 10% out. They adjusted it and they are now returning it to me reading correctly again. The problem I've got is I don't know when did it go 10% out. Did it go 10% out after the first test I used on, or was it fine the whole year and just went out on the last test, or even during shipment to the calibration laboratory? So because I don't know that, I now have to look at every test that I did and determine would a 10% variance spoil that test. And for anywhere where that 10% variance would spoil the test, I'm going back to retest. So Z662 looked at it and said, no, the calibration thing doesn't really work. Not for us in this circumstance, okay? Because what we've got is a history or an understanding in other jurisdictions, other countries, where they have the calibration requirement. When instruments come back out of calibration, people don't redo the test. They just say, it's probably close enough, right? And so we really didn't want to have that. And this is a second-party system, right? The company bears full responsibility. So if we trust the company to be using competent personnel, understand the concepts, the codes, the standards, all of the other, why wouldn't we trust the company to verify that their equipment is working properly at the time of the test? So to do a verification, what you'll typically do, you will have a deadweight tester, or you will have a gauge or something calibrated that doesn't leave the shop. Okay, and when it's time to do a test, the equipment you're going to be using in the field, specifically the chart recorders, are verified, right, against your deadweight tester. Then you go out in the field, you do the test, you bring it back, and you check the chart recorders again. Are they still reading accurately, or is it still reading accurately? That's what validates your test. Okay. Now, what a lot of companies do is they'll run 2 chart recorders. Okay, and most jurisdictions will accept this. If I verify that 2 chart recorders are working correctly, take it out into the field, do my test, and through the test they read identical, right? Statistically, that means I'm fine, because the chance of 2 instruments failing in exactly the same manner simultaneously, right? You've got better chance of being hit by lightning 3 times in a row. Like, it's just statistically, it's almost not possible. Okay, so that rationale is used, and that's why in the field you most typically see multiple chart recorders, right? Because again, these are for 24-hour, multiple hour tests, right? You don't want to do the whole test, everything's fine, go back to the shop and find out the recorder went out of calibration. Much better to run the 2 and have that indication there. The other instruments, again, it says verified. Again, we get to do it, but it says periodically. It even gives us the latitude of what that frequency is. Okay, it's just the primary recording instrument, the chart recorder, right, that needs to be verified before or after, or as accepted by industry, running multiples. So 8774 says that temperature recorders shall be used to monitor the ambient temperature and temperatures of the test medium of the pipe. That is a really valuable tool if you do have an anomaly and you need to verify it, right? That gives you something, because a lot of times pressure, in most cases, pressure fluctuations will be directly correlated to temperature variations. 8775 says that for each test section, records shall be prepared to give the location, pressure details, and the cause of any leak, rupture, or other failure in the test section, the description of any repair action taken, and the results and recommendations of the investigation shall be recorded. Now, where leaks occur during strength test and the required strength test pressure cannot be maintained, the piping shall be repaired and the strength test repeated. Where leaks occur during leak tests, the piping shall be repaired and the leak test shall be repeated. Now, this is very much in conjunction with the clause we looked at earlier, identifying the intent that we're not to be doing cyclic testing, especially on the strength test. So the wording here is very important. Where the leaks occur during the strength test and the strength test cannot be maintained, we will repair it. But if you have a leak during a strength test and you're able to maintain the appropriate test pressure range, the strength test pressure range, you keep that test going. Okay. Leaks and ruptures that occur during pressure testing shall be investigated to determine their cause and any potential impact on future operations.